This is an interesting problem here in this section on finding rational zeros, but it will allow us to take a look at a couple of different skills we might be able to pick up and learn. And so we see we got the volume of a rectangular prism. So I see a rectangular prism here, and it's got different measurements. One is W centimeters, and then W plus 1 centimeters, and then W minus 3 centimeters. I'm going to go ahead and read the problem. The volume of a rectangular prism is 1,056 cubic centimeters. The length is 1 centimeter more than the width, and the height is 3 centimeters less than the width. Find the dimensions of the prism. Well, in order to find the dimensions of the prism, I'm going to have to multiply W times W plus 1 times W minus 3 and set that all equal to 1056. Well, let's jump over and do that at least. Then we'll talk about the rational zero theorem. So here's our prism, and so I've got to then multiply. Let's see, we got W times W plus 1 and W minus 3. Everything's in centimeters. So I'm going to FOIL the W plus 1 and the W minus 3 first. And let's see, I guess I could put this is all equal to 1056, but we'll deal with that in a minute. So let's see, then we're going to have W times W squared minus 3W plus 1W, or just W, minus 3. That's going to equal 1056. Let's combine like terms. So now I got W times W squared minus 2W minus 3 equals 1056 cubic centimeters. And now let's distribute the W. And so now we've got a polynomial, W cubed minus 2W squared minus 3W equals 1056. And let's set this equation equal to 0, because we're really trying to find zeros of this. And so then we got W cubed minus 2W squared minus 3W minus 1056 equals 0. Now, the rational zero theorem would tell me that all the possible rational zeros of this polynomial is equal to all the factors of P over all the factors of Q. And of course, in this case, Q is 1. But I'm looking at that 1056 or negative 1056, and that is an awfully big number. I got a feeling there's a lot of factors of 1056. Oh my goodness. All right, we're going to go over to the calculator. We're going to do two things actually. I'm going to actually show you how you could actually find the factors of a large number like that. But that's not actually how I would solve this thing, and which is going to be the second thing I would do, which I'm going to graph it. But let's move over to the calculator, and then first we will explore how we can find the factors of a large number. I mean, I could start by dividing by 2, right? Negative 1056 divided by 2. It probably could take a while. All right, let's move to the calc. What you think? All right, we found ourselves with this rational zero theorem that we had a very large number. It was 1056. Actually, specifically, it was negative 1056, but I'm just going to use the positive version of that. And the first thing I want to do is I want to think, well, what are all the factors of 1056? Well, I can find that by going in here to y equals, and I'm going to say, you know what, I want to see 1056 divided by x. And I'm going to go to the table, and I'm going to start looking at the factors of that. This might be helpful in some other things. This is actually not actually how I'm going to solve all this. But let's see, let's go second graph. Let's look at the table. And I'm going to start down here. All right, well, 1 times 1056 that's a factor. 2 times 528, that's a factor. 3 times 352, that's a factor. 4 times 264 is a factor. The 5, I'm looking for integers. So when I see the 211.2, 5 I'm going to say is not a factor, but 6 is a factor. 6 times 176, that multiplies to 1056. 7 is not a factor. 8 is. 8 times 132. 11 times 96. 12 times 88. And it kind of goes on and on. Where's the next one? 16 times 66. That might actually help you in terms of trying to find the factors of a large number, hopefully not as large as 1056. But let's go back and see what I saw. Let's see, I saw 12, 11, 8, 6, 4, 3, 2, 1. Okay. Well, let's just graph this thing. How about that? If I remember correctly, and you may too, we had a function that was, let's see, it was w cubed. I'm going to substitute x for w. So I got w cubed minus 2w squared, or 2x squared we're going to use, and then minus 3w, or 3x, minus 1056. All right, I'm going to hit the graph. I think it's going to probably take a minute. Yeah, the little, okay, so it's finished graphing it. I can't even see anything within my window settings, and my window settings are at my default negative 10, 10. Let's go into the table and see if we can find a 0 fairly quickly. Oh, wow, all right, it's already up there. So when w is equal to 11, I do in fact have a 0 of this polynomial function. And so 11 is a possible answer since it's a 0. Now what I think I'm going to do is I'm going to go use synthetic substitution, and using 11 on that polynomial function. And let's see what we end up with there. See if we can see if there's any more real zeros in this function that are rational. Might finally be some irrational. So we had a function after we multiplied this times this of w cubed minus 2w squared minus 3w minus 1056. And I'm going to synthetically divide this by 11, which I already know I should get a 0 remainder because it's a function. So let's say I got a coefficient of 1, negative 2, negative 3, negative 1056. Now I'm really just doing this to check my depressed polynomial and see where I end up. So I bring down the 1. Okay, so 11 times 1 is 11. Negative 2 plus 11 is 9. 11 times 9 is 99. Negative 3 times 99 is 96. And let's see, I better figure out what is. Let's see, 11 times 96. Well, Shazam, that's 1056. And I got a remainder of 0. Now I'm looking at what would be this depressed polynomial of x squared plus 9x plus 96. I'm thinking, okay, are there two numbers that that would multiply to 96 and add to 9? Well, 8 and 12 would do it, but that's 20. I think 6 and 16 would do it, but that's 22. It's going in the wrong direction, isn't it? 4, well, 4 would go there, but that would be 24. That's 28. We're going in the wrong direction. And maybe I want to say, well, what would happen if I used the quadratic formula, of course, which is negative b, which would be negative 9, plus or minus 9 squared, minus 4 times a, which is 1, times c, which is 96. And that would be over 2a, but a is 1, so that's just 2. Well, 9 squared is 81, and 4 times 96, I have no idea what that is. It's going to be a pretty big number, close to 400 anyway, and it's going to be negative. So that means my square root is going to be negative. It's going to be an imaginary number. And really, 11, I think, is my only rational zero. Now, let's substitute in 11 for w, and let's get the dimensions of this rectangular prism. Well, that means that if I substitute 11 for w, I've got 11 centimeters times, let's see, 11 plus 1, that's going to equal 12, times 12 centimeters. And 11 minus 3, that's 8, times 8 centimeters. So it should be 11 times 12 times 8. Now, you know what I probably need to do? I probably need to multiply 11 times 12 times 8 and make sure that comes to 1056. And if it has, I've solved this problem. 11 times 12 times 8. Enter. Shazam! It equals 1056. That was kind of a bizarre problem. Got to think a little bit. Probably think a little bit outside the box. But hey, that's what math's all about. That's why we are persistent and patient, and we persevere, and we also use our practice to build our skills, because you too could be an excellent mathematician.